Oh my goodness, just did this whole video and it for some reason didn't work. Let me try it one more time. All right, so you want to figure out some equations from graphs that they give you. And if they tell you it's exponential graph, it's going to be this form, the equation that you're looking for. So if you see it's going to be exponential, like it curves up real fast like this, or maybe it curves down real fast, they're going to give you the hint y equals a times b to the power of x. And let's figure them out. Well, before we do that, let's make sure we understand what all these things mean. Okay. The a in this case is going to be a starting point. If it's a real world problem, it might be how much money you have now before you triple your money every 10 years or something. If it's just a regular equation, it's just simply your y-intercept. The b is the multiplier. Okay, and if it's what you're going to multiply over and over and over. If it's interest, it might be, the a might be $1,000 and b might be 4% interest. So the multiplier will be 1.04 times 1.04 times 1.04. So you just put 1.04 there to the power of x. The x is the number of times that you're going to multiply it by. So maybe it's the number of years if it's interest or something, or the number of months or whatever. Okay. And then let's go back to the multiplier. If the multiplier is bigger than 1, so if b is 1.5 or 2 or 3 or something, then you're going to have exponential growth. It's going to get bigger. It's going to look like this equation right here. If the b is a fraction between 0 and 1, then it's going to be decay. So it'll look like this graph. Oops, let's get back up there. It'll look like this graph right here. So, and there are other situations, like special situations, if b equals 0 or if b equals 1. I'm not going to get into that into this video. We'll talk about that in class. And b, for our purposes, will not be negative. So as long as b is positive, we're going to have this exponential growth and decay. All right, let's try some problems. I have 5 problems set up here for you. First one, let's get a pen. Let's go blue. If this is a multiplying problem, right? This is a multiplier. All we have to do first, because right away I already know my a. They give us 2 as my a. So I know it's y equals 2 times something, just to the power of x. Well, what's that something? It's a multiplier. What am I multiplying the 2 by to get 6? Basically is what I'm doing. Because I'm only going 1 unit to the right here. So I just need to know what my multiplier is. The quickest way is 6 divided by the 2. Like this is 0, 2. As long as I'm going from here to here is just 1 unit, you simply have to divide the y values. 6 divided by 2. Now this is obviously, you can do it in your head, but sometimes it's decimals or some big numbers. So divide 6 divided by 2, we get 3. So my multiplier is 3. So just write 3 to the power of x. Now typically, you might see parentheses here. This looks a little bit better. There's our equation for that exponential growth curve. Number 2, same situation. Okay, we already know our intercept is 3. So let's start there. Y equals 3 times my b, my multiplier. Now it's a multiplier, so let's keep it as a multiplication, not division, even though it works the same. But let's leave it a multiplier. Now you might see this is 0, 3, and say, hey, 12 divided by 3 is 4, so it's times 4 to the power of x. But times 4 to the power of x is exponential growth, because that 4 is bigger than 1. It would be going up. So if the point right here were 12, that's the curve that you'd be graphing. Here it goes down to the right. So be careful. When you divide, always divide the one that's furthest to the right divided by the one to the left. So it's 3 divided by 12, not 12 divided by 3. So I would leave them as fractions, okay? And you'll see it that way also all the time. So this is 1/4, so it's times 1/4. I'll put parentheses to the power of x. Like that. All right, so let's move on to number 3. Now, this one's a little tougher. It's not obvious where the y-intercept is. Okay, it's in here somewhere. And the decimals are kind of scary looking, but it works the same way. The main thing is I notice it goes from 3 to 4. So this way it only goes 1 time, it's multiplied 1 time. So simply do the same process. Do this divided by this. Now I don't know what the y-intercept is, so I'm just going to have to go like y equals a times my multiplier. So I'll just do 10.125 divided by 6.75. Divide that out, and it's going to come out to be 1.5. All right, so that's my multiplier, 1.5 to the power of x. Now we're not done yet. We still have to find that a. So what are we going to do? Well, just like we have our y equals mx plus b stuff with our lines, let's say we knew it's y equals in this case 1.5x plus b, wouldn't we simply take one of the points and plug it in for x and y and solve for b? That's all we're doing here. Okay, so just take, same thing, take one of the points, let's say this one, plug it in for x here and y here, and solve it for a. So I'll do that over here. Y, oops, sorry. Y is 6.75 equals a times 1.5 to the power of x, which is 3. Okay. Now to solve this, divide both sides by 1.5 to the power of 3. Now if you want to get that answer, that's fine. It's not really necessary. It's quicker if you just leave it like this. So a equals, and just type in your calculator, 6.75 divided by, it'll look like this on a graphing calculator, 1.5 to the third power. That's what it'll look like on your graphing calculator. Okay, and you'll simply get 2 as an answer. Nice round number. So this curve, let me get rid of it here. This curve will go through 2. Nice. You get the idea. I'll try it one more time. Not bad. Make a big dot there. Okay. So our equation, y equals a, don't forget to go back to the y and the x now for generic for all the points. A, which we just found to be 2, our y-intercept, times our multiplier to the power of x. You can handle that. Moving on, number 4. All right, we have the y-intercept. Looks simple. Y equals 7 times my multiplier. Well, what's my multiplier? Well, if I do 56 divided by 7, that's easy enough. That's 8. The problem is this distance from here to here is not 1 unit. It's 3 units. So I will show you somewhat of a shortcut here, and then I'll show you a longer way in the next problem. This multiplier is 8, but it's multiplied 1, 2, 3 times. So it's kind of like saying something times something times something. Some multiplier is the same as a multiplier of 8 over the distance of 3 here. Or x cubed is 8. To solve this, you undo it by taking the cubed root of 8. Or just do it in your head. What times what times what gives me 8? You will get 2 as an answer. So it's like doubling, doubling, doubling. So think about that. 7 doubled is 14. 14 doubled is 28. Wait a minute. 14 right here. 28 here. And then double that to get the 56. So it makes sense. So it's times 2 to the power of x. There's my equation. Not too bad. Okay. If this is 3 sections. That's why you have to think something times something times something is that 56 divided by 7. If it was only 2 sections, then you just divide those out and then you take the square root because there's only 2 x's that you have to worry about. If it's 4 sections, you have to take the 4th root, which is what this next problem is going to be. Okay, so let's look at this one. I'll do the shortcut first, and then I'll show you the algebraic way to do it. You need to know both. So 324 divided by 4, that's 81. 32 divided by 4 is 8, and that's 1. So it looks like my multiplier is 81, but it goes from 2 all the way to 6. I'm looking at these numbers here. 2 to 6 is 4 units. It's not just a single unit. If it was a single unit, my b would be 81. It's 4 sections here, 4 intervals. So I have to take the 4th root. That's the fastest way. Or just think something to the 4th power is 81. Okay, that's something, the answer in your head is going to be 3. On a calculator, you just take the 4th root like this. Okay, now if you happen to have a graphing calculator handy, you should probably know how to do this. You need to type the 4 first for the 4th root. Go to your math key, and I believe it's number 5 if I remember correctly. If it's not, let me know. And the 5th one down should look like this. That's what you're looking for. It's the xth root, because you could take the 5th root, the 6th root, whatever you want. The 4 going first is kind of like making it substitute in for that 4. And then you want to hit 81 right after that, which kind of puts it underneath there. So 4, math, 5, 81, and then enter or equals. That's kind of the key sequence here to get this answer. Okay, so our multiplier, I'm calling this x. It's really, in this case, my multiplier is b. So this should really be b's, but it's the same thing. So we have y equals A, now we didn't know, if you look at this problem here, I can't tell, they didn't give it to us, what that y-intercept is. So for now, I'm just going to have to leave it A times B, which is my multiplier, we just found out to be 3 to the power of x. I'm going to erase all this mess here and use this information to come up with my y-intercept right there. So what is this point? It's real small. You know, I'm zoomed way out here, so it might be a 1 or a 2 or a 3 or something, but it might be a fraction as well. So it's right above the axis here. So how do we find it? Just like we did before. Plug in one of the ordered pairs for x and y and solve for a, just like finding our y-intercept from linear. So I'm going to use this x and this y. So I'm going to have 4 equals a times 3 to the power of x. In this case, it's 2. So 4 equals a times 9. Divided by 9. Nice 9. A equals 4/9. Kind of goofy. Typically, our a is a normal number, like a 1 or a 2 or a 3 or something. We can have fractions, though. They can be intersections of fractions, or y-intercepts of fractions. So here we go. My y-intercept is 4/9. My multiplier was 3 to the power of x. Put parentheses around that. There's our answer. Okay, that's the fastest way you can do this as far as I know. Okay, now let me show you the algebraic way, because you need to be able to understand both of these. Even if I don't ask it in the near future, you know, for me right now, this method is totally fine. Keep doing this. For future math courses, you need to know how to do this. And for other teachers, they might make you show this work. So that's why I need to show you this at least one time here in the video so you can study it. Here we are. We have 2 points, and we know they both work. They both solve this exponential equation. So let's plug them in and see what happens. 4 equals a times b to the power of 2. Like this is x and y. This is x and y. This one over here too. 324 equals a times b to the power of 6. Okay, now just like when we had systems before, we have 2 equations and 2 unknowns. So we have an a and a b are unknowns, and we have 2 equations. Just like our x's and our y's when we did systems that we solved for by substitution or elimination, okay, or equal values, we're going to do the same thing here. So let's solve them both for one of the letters, just like we'd solve them both for y, let's say. In this case, I'm going to solve them both for a because that looks like the easiest one. So if I divide by b squared, I get a equals 4 over b squared. Over here, if I divide by b to the 6th, I get a equals this mess right here. So 324 divided by b to the 6th. Okay. Now here I have 2 things equal to a, and they're on the same curve. They must be equal to each other. Both equal to a, so they're equal to each other. So I'm going to go like that. Just like if it was y equals 6x plus 2 in some equation, some linear equation or linear system equals 4x minus 9. They both equal y, so I can make them both equal to each other. Same thing as before. So I'll get rid of that. So at this point, if they're equal to each other, I can get rid of these a's, just like I could get rid of those y's before, like substitution, and then solve it. So let me delete this. If you want this erased, you might want to pause it and write it down. Just want to give myself some space here. Now, how do we solve this? My suggestion, cross multiply. Now you can use fraction busters, but I think this is going to be the easiest at this point. You could also move these up to the top and make it like b to the negative 6th and b to the negative 2nd and work that way. I think this is going to be the easiest. 4 times b to the 6th, 4b to the 6th, equals this times this, 324 b squared. That looks like a little easier to solve than that. Now we have variables and numbers. Put the numbers on one side and the variables on the other. I'll divide by 4. It looks easy enough. So b to the 6th equals, this is 81, just like we got before. Okay, at this point, I need to get rid of the variable. So divide by b squared. I need to put the variables on the same side. So since I'm multiplying here, I need to divide to get rid of it. So I have 81 equals, now what is b to the 6th over b squared? Hopefully you understand by now. It's b to the 4th. There's 6 b's on top, 2 on the bottom. Cancel, cancel. Okay, b to the 4th is 81. We solved just like before. Take the 4th root, So we get b equals 3. I'm not going to show you that work because we did it before. So b is 3. All that work just to find b. So I'm going to erase all this and write what we have. So y equals a, we didn't find yet, times b, which we just found was 3 to the power of x. And then just like before, I'm going to take one of these points, so plug it in for x and y, and solve for a. Just like we're finding our y-intercept. So 4 equals a times 3 to the power of 2. Just like before, exactly the same process. This is 9. Divide both sides by 9. A equals 4/9. So our final equation, y equals my 4/9, because that's my y-intercept, times my multiplier, which was 3. It triples every time, to the power of x. Yeah, I understand that's a longer and more tedious, but you should be able to follow that. You should be able to understand that. This is a quicker way to do it. Quick review. Divide those numbers. Get the answer is 81. It's like a multiplier. The thing is, it's 4 sections, okay, 4 intervals. So if the multiply times multiply times multiply like this, multiply, multiply, multiply. So it's 4 times we're multiplying. So take the 4th root of this to get the actual multiplier from here to there. If we don't know our a, then simply write this equation, plug in one of the points, x and y, for x and y, and solve it for a. And then put in our information for a and b. Leave it in generic terms with y's and x's. So we have it for all the points. All right, I hope that was helpful. Good luck.